Let's go ahead and start question number 11a. So for this question, I need to find x so that the values given are consecutive terms of an arithmetic sequence. Okay, so for this problem, there's one little concept that you do need to understand. Let's label this as the first term, the second term, and the third term. And let me just pick some random numbers here like 3, 6, and 9. Okay, so here is my very short arithmetic sequence. And if you want to find the common difference, you would pick a term. So for example, if I pick term 2, then you need to subtract the first term, which is the previous term from term 2. And if you do that, you would get 6 minus 3, and my common difference is going to be 3. And that's pretty obvious, right? Because you're just adding 3 to your sequence. Now, when you're finding the common difference, it should be consistent throughout the sequence, and it doesn't really matter what term you pick. As long as you subtract the previous term, you should always get the same common difference. So for example now, if I picked term 3, I need to subtract the term previous to it, and that's going to be term 2. And so in this case, term 3 is going to be 9, and term 2 is going to be 6, and 9 minus 6 is going to be 3. So you'll notice that the common difference is going to be the same regardless of where you start. All right, so I can pick term 2 or I can pick term 3. As long as you're subtracting the previous term from that, you can always find the common difference. All right, so in order to solve the questions on number 11, you need to know this concept right here. All right, so if you want to find the common difference, you take your second term minus your first term, and you make that equal to your third term minus your second term. Okay, so let's go ahead and apply that to this particular problem here. So this is going to be your term 1, this is going to be term 2, and this is going to be term 3. All right, so if I do term 2 minus term 1, that's going to be 2x plus 1, subtract term 1, which is going to be x plus 3. And that's going to equal to the third term, which is going to be 5x plus 2. And then I'll subtract that from the second term, which is going to be 2x plus 1. All right, and then we have a simple grade 9 level problem here. Let's go ahead and solve this. So 2x plus 1. And then I can distribute the minus sign, so I get negative x minus 3. And that's going to equal to 5x plus 2. And then I can distribute the minus sign here, so I get negative 2x minus 1. All right, and then on the left-hand side, let's just collect like terms here. So 2x minus x is going to be positive x. And plus 1 and negative 3 is going to be negative 2. So 1 minus 3 is going to be negative 2. And that's going to equal to, and if I collect like terms on the right-hand side here, so 5x minus 2x is going to be 3x. And 2 minus 1 is going to be positive 1. All right, and then I just solve this particular equation here. So I'll leave the 3x over here. Then this x I'll move to the other side, so that's going to become negative x. The minus 2 would be on the left-hand side, and then this positive 1, I'll make that into a negative 1 on the left-hand side there. All right, so 3x minus x is going to be 2x. Negative 2 minus 1 is going to be negative 3. And then I divide both sides by 2. And there's my answer of negative 3 over 2. All right, so that's it for question number 11a. Let's move on to 11c here. So similar type of problem, just different kinds of variables and numbers here. So this is term 1, this is term 2, and this is going to be term 3. So let's start off with term 2 minus term 1. So term 2 is going to be 1/2 x plus 4. And then I'm going to subtract that from term 1, which is going to be x minus 1. And then I'm going to make that equal to term 3, which is 1 minus 2x. And then I will subtract that from the previous term, which is term 2, which will be 1/2 x plus 4. Okay. And then on the left-hand side here, let's go ahead and simplify this. And we can distribute the minus sign here. If I do that, I get negative x plus 1 equals to 1 minus 2x. And then this minus sign here, I can distribute that through. This one's not too bad. This will be negative 1/2 x and then minus 4. All right, so let's go ahead and collect like terms here. If I have a half of x and if I minus 1 full x, so that's the same idea as 0.5 minus 1. Well, that's going to be negative 0.5, right? So I'll leave this as negative 0.5x. And then plus 4 plus 1 is going to be plus 5. Okay. And then over here, I have a negative 2x minus 1 half. So that's the same thing as negative 2 minus 0.5, which is going to be equal to negative 2.5. So I'll leave that as negative 2.5x. And then I have a 1 and a minus 4. So 1 minus 4 is going to be negative 3. All right, so now we're in a very similar situation to the previous question where I have some variables on the left-hand side and some numbers on the right-hand side. So let's go ahead and just interchange those two terms. So the negative 0.5x, let's move that to the right-hand side, and that negative 3, let's move that to the left-hand side. So sorry, I'm not sure if I said that correctly. The negative 0.5x, we want to move that to the right-hand side, and the negative 3, let's move that to the left-hand side. Okay. If I do that, I get a 5, and then we get a plus 3 here. So negative 3 becomes positive 3. And then I have the negative 2.5x here. And then if I bring this one over, that's going to be positive 0.5x. All right, so let's go ahead and keep on simplifying here. 5 plus 3 is going to be 8. Negative 2.5x plus positive 0.5x is going to be negative 2x. And then finally, we get some nice numbers here. I can divide both sides by negative 2, divide by negative 2. 8 divided by negative 2 is going to be negative 4, and that's going to equal to the value of x. All right, so that's it for question number 11C. All right, let's move on to a few final questions here. I believe this is number 12 here. So if Tn is the term of a arithmetic sequence, now Tn is generally the last term, and we need to figure out what is the last term minus the Tn minus 1 term, and basically this is the term that's previous to the last term, right? So Tn, this is the last term. All right, so if you have a sequence here, I don't know how many terms there are in the sequence, but let's just say this is Tn, the last term. And then this guy right here, Tn minus 1, this minus 1 means we want to be in the term previous to the last term. So this is going to be Tn minus 1. All right, so this is very similar to question 11, very similar to question number 11, where this is really the common difference problem. Basically, if you take any term and if you subtract the previous term, you're left with the common difference, right? So any term minus the previous term is always the common difference. So that's it for question number, I believe this is 12. It's just a theory question there, so nothing more to it. All right, let's move on to question number 14 and 15, a few word problems here. Okay, so not too bad. The starting salary of an employee is $23,750. So this is your first term. And each year, we're given a raise of 1,250. So this is really your common difference. And in how many years, if we're being asked how many years, that's really the number of terms. And how many years will it take for the salary to reach $50,000. And this is really your last term, right? So I want to figure out how long it's going to take to get to $50,000 if I'm given this starting salary and this common difference, right? So we can start off this problem by writing out the formula for arithmetic sequence here. Okay, so what is Tn? Tn is your last term, and I want to figure out how long it's going to take for me to reach $50,000. And what's my starting salary? My starting salary is $23,750. And then plus, I want to figure out how many years it will take. So I'm looking for the value of n. So n remains, and my common difference is the amount of money that I receive in addition every year, my raise. So that's going to be $1,250. And now all I have to do here is solve for the value of n. Okay, so let's go ahead and subtract the 23,750 from both sides. And for sure, definitely use a calculator here. think for these word problems, having a calculator is totally appropriate. And if I use my calculator there, I get 26,250. And then over here on the right-hand side, I get n minus 1. And then multiply that by 1250. All right. And now in order for me to get rid of the 1250, I would divide both sides by 1250. And now we can just divide, we can go to our calculator again and divide by 1250. And if I do that, I get 21. So 21 equals to n minus 1. And then I can add 1 to both sides and I get 22. So it's going to take roughly 22 years for me to reach a salary of $50,000. Okay, let's move on to the last question for this homework video guide, question number 15. So an auditorium has 8 seats in the first row. So in the first row, there are 8 seats. And then for each row that we have 4 more seats than the previous row. So in row number 2, I'll have 4 more. So that means there are 12 seats in row 2. And just for practice, for row 3, I'll have 4 more. So 12 plus 4 is going to be 16. And then the sequence will continue on. And I want to figure out what row has 140 seats. All right, so I want to figure out what term number has 140 seats. Okay. All right, so let's go ahead and write out the formula for the arithmetic sequence here. So a plus n minus 1 times d. Okay, so Tn is really your last term. So my last term has a value of 140. So 140 would go there. Equals to a, which is my first term. And my first term is going to be 8. So 8 plus, now I don't know what term number that is. So n minus 1. And my common difference is just plus 4, right? We're going up by 4 each time. Okay, and then just like the previous problem, we're just solving for the n variable here, so I can subtract 8 from both sides. So 140 minus 8 is going to be 132, and that's going to equal to n minus 1 times 4. Then in order to get rid of that, green 4, I can divide both sides by positive 4. So 132 divided by 4 is going to be 33. Equals to n minus 1. And then n plus 1, sorry, if I add 1 to both sides, I get 34 equals to n. Okay, so in the 34th row, I would have 140 seats. All right, so that's it for this homework video guide on section 6.5.